Hi there, welcome back to the channel. And in this video, we are going to be discussing acidity and alkalinity. All right, and this is a follow-up video on the on the acid, base, and salt video that we have made, and where we discussed acids, discuss alkalines and bases. All right. So, but in this video, what we basically want to talk about is the calculation of the pH. So, basically, want to talk about the pH scale. Okay. But quickly, let's remind ourselves of some of the things that we have discussed in the previous video. We said that acidity was defined according to three persons. We first talked about Arrhenius, that Arrhenius defined an acid as a substance that produces hydrogen ion or hydrozonium ion when dissolved in water. All right, so we said if you ionize, for example, HCl, now it would give hydrogen ion, that is proton, or if it dissolved in water if it ionized by dissolution in water, then you have hydrozonium ion, so that you have H3O plus Cl minus. All right. Now, in further video, I'm going to analyze what this actually means. So that is according to Arrhenius. We also discussed acid as defined by Lewis. So Lewis acid was defined as any electrophilic compound that can, accept an electron pair, to form a dative bond or coordinate covalent bond. All right. So that is definition according to Lewis, an electron pair acceptor. Then the Bronsted-Lowry also defined acid as a proton donor. So which is basically that if this guy reacted with a metal and, for example, an alkali, for example, is going to donate this proton, and the metal will react with the other component. So this guy donates proton. It donates proton. So it protonates other compounds or other atoms. So that is according to Bronsted and Lowry definition of an acid. All right. Now, what is a pH scale? A pH scale. So acidity is how much acidic a substance is, while alkalinity is how much alkalinic a substance is. All right. But based on pH scale definition, we say that acidity is how much of hydrogen ion concentration or how much of hydrozonium ion concentration. Basically, we are talking about the same thing here. All right. So when we say hydrozonium ion, you know that water is involved, hydrozonium ion. So how much of hydrogen ion concentration or how much of hydrozonium ion concentration was present in a particular thing? That's when we call that's what we refer to as acidity. Then alkalinity, we'll talk about how much of hydroxide ion concentration in a substance. All right. So a pH scale is a scale that ranges from 0 to 14, that shows how the degree of acidity or alkalinity of a substance. Now, it's basically a scale that a logarithmic scale. First, number one, it is a logarithmic, and number two, it also has color. It shows, the color gradients of different substances based on their alkalinity or acidity. So we said it ranges from 0 to 14, and there is a midpoint here, or a point of neutrality, which is the point of neutral pH. So, and here is where water, the water that is suitable for drinking, or water that is not contaminated, it exists has this pH of 7, neutral pH. It is neither alkalinic nor acidic. Now, this is the way it is read. Now, the more you tend towards it, I'm going to talk about the color gradients in a while, but I'm going to talk about the way the scale is read. Now, the more you tend towards this direction, the leftward direction, the more acidic you are. So that a material, or a compound, or a substance having a pH of 6 is not as acidic as another substance having a pH of 3. Is that okay? Now, and a substance having a pH of 8 will not be as acidic as alkalinic. So we said this is alkaline and acidic. So the more you tend towards it, a substance with pH of 8 will not be as alkalinic as a substance with a pH of 13. So the further to the right that the pH value of a substance tends, the more alkaline the substance is. And the more to the left that the pH value tends, the more acidic the value is. All right. Now talking about the color gradient, we have the Roy-Gibbs spectrum. Roy-Gibbs spectrum is used to denote the pH. So when a substance appears, it stands for the red, orange, yellow, green, blue, indigo, and violet. So around this spectrum, around green and colors that are very close to green will be the neutral point. While as you tend towards red, the substance is more acidic, and as the substance color tends towards, not the substance color anyway, but that the color change that is observed when the pH of the substance is tested. So when the color change tends towards blue, indigo, and violet, then the more basic the substance is. All right, so if I said a substance was tested and the color change that was observed was orange, now what quality does that substance contain? I mean, what quality does it have? Then the quality is acidic quality, because it is an acid that has that shows that color change. All right. Now, we have some calculations here to solve. But before we solve those calculations, let's talk about some formulas that are used to calculate pH. I just told you now that it's a logarithmic scale. So when I say 1, it is not just 1. 1 as a logarithmic number. All right, let's use our knowledge of logarithm here. Now, the first equation is that pH is equal to the negative force. What is pH? pH means power of hydrogen, or potency, power or potency of hydrogen. All right, so pH is given by the formula the negative logarithm of hydrogen ion concentration, or you say to the base of 10 is in base 10, or you say pH, or you say pH, or P hydroxonium ion. Is that okay? pH actually is minus logarithm of concentration of hydroxonium ion. Either ways you write it, you are correct. It's pH, not P hydroxonium ion. All right. Now this is the first equation. Now the second equation is that if you are not acidic, pH is the degree of acidity. Then pOH will be the degree of what? Alkalinity. So pOH is going to be the negative logarithm of hydroxonium ion concentration to the base of 10. That is pOH. All right. Now, using this equation 2, this is going to be equation 2. Now, using our knowledge of logarithm, we can form another equation from here so that pH will be equal to, if pH is equal to minus log of H plus concentration. So what do we say? We say that to get this, we say that this guy can push this guy up, and then we have the concentration of this guy. So we have the second equation, so this is first equation, second equation. The third equation is going to be that H plus concentration is equal to 10 raised to the pH. Now listen. Because of this minus, let's redo that. Because of this minus, what we are going to have is this, that this minus will come up here. So we have log of H plus minus 1 raised to the power minus 1 is equal to pH. Does that make sense now? So this guy pushes this guy up, and then it will be equal to this guy. So we now have H plus raised to the power minus 1. Now, we are going to, bring this value here to this side, to the right. So this power, negative power. So that becomes H inverse will go to, so what we have naturally is H inverse is equal to 10 to the power pH. Is that okay? So this becomes H plus equal to 10 raised to the power minus pH. Does that make sense? Now, if it's confusing on how I did this, it is simple. Simply say that if the inverse of this is this, then this itself will be the inverse of this. That is what it's saying. All right. So this is equation 3. Equation 3. Now, the other equation is going to just be this one. So we can also form that this OH minus concentration is equal to 10 raised to the power minus pOH. All right, look at the way it is written, small letter p and capital letter H. All right, then the fifth equation is this. Now, on that scale, we said it ranged from 0 to 14. Now, it is the addition of the pH of the addition of pH value and pOH value that gives that 14. So we have that pH plus pOH is equal to 14. Well, that value is not necessary. So pH plus pOH is equal to what? 14. Now, from what we have here using our knowledge of logarithm, we can have a sixth equation. From what we have here, since this value plus this value gives 14, definitely means that the concentration of H plus times the concentration of OH minus, will give us 10 to the power minus 14. Because the concentration of this is P raised to the power minus pH. And the concentration of this is P raised to the power minus OH. Now, if you use the knowledge of logarithm that we already had before, multiplication of this is this addition. This equation came from, if you go back to the logarithm video, this came from minus log concentration of OH. So, concentration of H plus minus log concentration. So, if you multiply these values, so that what you have is this, minus log to the base of 10 of H plus, is that okay? Plus minus log minus log this of OH minus is equal to 10 is equal to 14. Because we say this pH plus pH is equal to 14. So what do we have? Then it means that we have log of H plus times OH minus. Is that okay? So that was how we came about this. Then 10 will kick 14 up, and then we'll have that. Is that okay? All right. So, what we did is to collect minus log 10, and multiplication, addition of these results will give us the log of these results will give us the multiplication of the results. All right, so that is a log logarithm. Check out the video on logarithm, and you will be good to go with that. So these are the six equations that we need to memorize to solve this. Please, if you don't understand the way I came about these equations, go back to the logarithm video that I'm going to link in the description below, so that you can understand this very well. All right, let's go on to solving these questions. Now, you will need a calculator in order to be able to solve this question. All right, because this is logarithm that you need table for. It's not logarithm that you can easily solve without table. All right, so the first one says that we should calculate the H plus concentration, this and this and this, OH minus concentration, pH and pOH of a solution of this or NaOH. All right, so NaOH is going to ionize. So we are going to ionize it first. Now, this is because the compound is given. In this other question, I don't think a compound is given, so we don't need to ionize. But the reason why I'm solving this is because of the essence of why ionization is necessary. If I ionize this, I'm going to have Na plus OH minus. Is that okay? This is the ionization product of this. And this guy is containing 0.02 molar. All right. Now, what you now observe is how many ratio of this give rise to this. This is in the ratio 1, ratio 1, ratio 1. So because of that, this is also going to contain 0.02 molar of Na sodium ion and 0.002 molar of hydroxide ion. All right. So having done that, so in that case, it means that if I have an acid like H3PO4, if I were to solve for the if I want to ionize it before I solve, so it will give me 3H plus PO4 minus. All right, 3 minus. So if I have like 0.05, for example, molar of this guy, then it means that on this place it's going to be 3 times 0.05 because it's ratio 1, ratio 3, ratio 1. Is that okay? Why here I have 0.05 molar? Is that okay? So that is the essence of the ionization here. So seeing that nothing is changing here, we'll just go on to solving it directly. Now, it is easy here to basically estimate the OH first, to calculate the pOH first. So we have that pOH is going to be equal to negative logarithm of the OH minus concentration to the base of 10. All right, so we have the concentration of this. So pOH is going to be equal to minus log to the base of 10 of this concentration, 0.02 molar. All right, and that becomes pOH is going to be minus log of to base 10 of 2 by 10 raised to the power minus 3. 1, 2, 3. So minus 3. All right, so this becomes pOH. Now you can basically just type that into your calculator, you get your answer. I think, yes, you can just type this into your calculator. But if you want to begin to solve, now it's easy to determine the value, the value of your what answer you will get here is easy. You can know if you are correct or not. That's what I wanted to say. You can know whether you are correct or not. Now your answer is going to be around this value 3, and I'll show you how by solving logarithmically without using calculator first. Well, at the end of the day, I'll still use calculator, but look at something. Your answer is going to lie within this 3, around 3. So the answer will be between 2 and 3 or 3 and 4. Now, how do you know whether it will be in this lower side or the upper value? Now, you will know if it will be the upper value. If this number here, if it is greater than 1, then it will be in the lower boundary here. While if it is less than 1, to be in the upper boundary here. All right, let's solve that first with a calculator. Now, by using a calculator, I have negative logarithm of, open brackets, 2 times 10 raised to the power, I hope the camera can capture this, 2 times 10 raised to the power minus 3. That gives me 2.69. So 2.69 is approximately 2.7. So the answer I'm expecting is 2.7. So, and I just told you that we have 2 boundaries, upper and lower boundary. Now we are going to get the lower boundary because, between 2 and 3, because this number is higher than 1. So if it's higher than 1, you get the lower boundary. If it's less than 1, you get the higher upper boundary. So that's why our answer is 2.7. All right, let me solve that using logarithm. So it's going to be minus log to the base of 10 of 2. Now plus, remember that our rule of logarithm says that if it is multiplication, it means it came from plus negative logarithm, again, is that okay, of 10 raised by minus 3 to the base of 10. So pOH becomes minus log of 2 to the base of 10. Now we cannot evaluate this with our brain, so with our head, so we are going to use calculator for that. But this becomes plus minus, now this one comes here using rule of logarithm, so you have this, is that okay? Minus comes to the back, and you have log of 10 to the base of 10. Now remember, log A base A is equal to what? 1. So this becomes 1 essentially, so you have pOH to become minus log 2. So just basically type in your calculator minus log 2. That becomes minus 0.301. All right. Now this becomes plus, minus by minus is plus, so plus 3. This has become 1 using this principle of logarithm. So we have pOH will be equal to 3 minus 0.301, and you have 2.7 approximately. All right, which was our answer here. So now what I'll do is I'm going to solve. Now I'll solve one more here. I'll leave you to solve the rest. I'll leave you to solve the rest. So because of time. So look at this pOH. So I've solved pOH. So you can basically say, how do you solve the pH now? So the pH, since pH plus pOH is equal to 14, what do? You already have your pOH. So you just say 2.7 is equal to 14 plus pH. So pH will be equal to what? You subtract it, right? From both sides. So you have 14 minus 2.7. And pH will be equal to what? This minus this. 12 minus 7, 0.7, that is 11.3. And that is your pH. Is that okay? Now, you can apply the same step for the hydrogen ion concentration. For the hydrogen ion concentration, you just make your, since pH is already minus log of H plus concentration to the base of 10. So this guy comes, and your pH, you've gotten the value of your pH to be 11.3. So you basically bring this guy up. So you have H plus ion will be equal to 10 raised by minus 11.3. Is that okay? So, and that becomes your answer essentially. 1 times 10 raised to the power minus 11. And so that's that about it. So you can solve the rest. You can solve for pOH. You can solve for pOH. All right, let's go on to the second one. The second question says that calculates pH. I'm going to solve one as well here. All right, so that you can have questions to solve as well. pH of this. Very simply, you've been given the concentration of this. Okay, in this case, I'm going to solve pOH. pOH. Now look at the way I'm going to solve it. I could solve anyone. Look at what I'm going to do. First, I have to get solve pOH. I need the concentration of hydrogen. So let me solve the concentration of hydrogen. So recall that H plus OH minus concentration is going to give us 10 raised to the power minus 14. So if that is the case, we already have the concentration of this guy as this. So we have 4.1 times 10 raised to the power minus 14 molar, isn't it? So times concentration of OH minus is equal to 10 raised to the power minus 14. All right. So how do we get this concentration? It becomes OH minus is equal to 10 raised to the power minus 14 divided by 4.1 times 10 raised to the power minus 14. All right, this becomes OH minus is equal to, this is 1 over 4.1. Is that okay? Times 10 raised to the power minus 14 divided, is that okay? Divided by 10 raised to the power minus 14. Because this is under. Is that okay? All right, so you have OH minus is equal to, you use your calculator for this, times 10 raised to the power minus 14. This is 14. Is that okay? Let me check if the question is 14. Okay, it is 4, not 14. It is 4. So this is 4, this is 4, this is 4. Yes. Okay, here is 14. So here is 14, here is 4. Is that okay? The question says raised to the power minus 4. I mistakenly wrote 14. All right, so we have that 10 raised to the power minus 14 here. Now, division means minus, then minus the initial minus that was there, minus 4. So let's use our calculator for 1 divided by 4.1. 1 divided by 4.1 is equal to 0.24, 0.2439. Let's just say 0.24. Then times 10 to the power, so we have 0.OH minus concentration is equal to 0.24 times 10 to the power minus 14 plus 4. Exactly. So we have OH minus concentration is equal to 2.4. Now let's change it to standard form. This to standard form becomes times 10 to the power minus 1, right? Then times 10 to the power minus this plus this is equal to minus 10. Is that okay? So you bring this together again. So that becomes 2.4 times 10 to the power minus 1 minus 10. That becomes what? Minus 1 plus minus 10, plus times minus minus. All right, so you have 2.4 times 10 to the power minus 11. And OH ion concentration becomes what? Equals 2.4 times 10 to the power minus 11 molar. And that is your answer. So we've gotten OH ion concentration. So you can solve for the pOH, and the answer you get, you subtract from 14 to get the pH. You see how simple that is? All right, so in lieu of that, I'm going to leave you to solve number 3. I want you to provide the answers to all of these questions I've asked you to solve down in the comment section below. And if you are wrong, I will let you know. If you are correct, I will let you know. All right, that will be it for this video. See you in the next video where I'll be discussing other aspects of chemistry. And this, we have begun our series on chemistry. So make sure to stay tuned for the next class where we'll be discussing many things that you need to know in chemistry. See you in the next class. And do well to subscribe to the channel if you have not already, please, since you gain value in this video, and also extend the video to other persons that you know will need it. See you in the next class. Thank you.